Hi guys, me again. I hope that the mean, median, and mode went well for you and that everyone is making sense of that. As I mentioned before we left, or before I left, I'm going to skip around a tiny bit so that we can do the variance and the standard deviation when I'm back with you. I just think that will be easier. There were a couple of sections near the end of chapter 3 that are fairly straightforward that I think you guys are aware of and you know how to do these things. So that's what we're going to talk about today. Everything's pretty much going to be on a PowerPoint. The PowerPoints are actually kind of nice for this because they already have the examples kind of laid out for us so we can not have to write so much down, and hopefully it will make sense. So hope that you enjoy, and good luck, work hard, and I will see you soon. Here we go. So here's the PowerPoint for this, I think. There we go. So this section is 3.5 on measures of position, including quartiles and interquartile range, and also percentiles and percentile rank. So the first thing here is the definition of a quartile. Quartiles are 3 summary measures that divide a ranked data set into 4 equal parts. So it sounds kind of interesting, but there are only 3 quartiles. There's the first, second, and third quartile. But if you think about taking a strip of paper or anything and splitting it into 4 parts, you would make 3 cuts. So that's how you have to think about the quartiles, as sort of like the cuts in the data that splits the data into 4 equal parts. The second quartile is the same as the median of a data set, so that's just right down the middle. Then the first quartile is the value of the middle term among the observations that are less than the median. So you look at the bottom half and you find the median of the bottom half. And then the third quartile is the median of the top half of data. So here's kind of a pictorial representation of that. Sorry, I just thought I could maybe squeeze that in a little bit better. Yeah, so each of the portions contains 25% of the observation. So here you can see, again, 3 cuts, which splits this into 4 equal parts, all 25%. Okay. In order to calculate the interquartile range, that's the difference between the third and the first quartile. So you basically take whatever number is at Q3, the third quartile, you subtract Q1. That's the interquartile range. And so that kind of tells you the spread among the middle 50% of the data. Because, of course, as we've seen in other data sets, sometimes we might have outliers, that land out here or land out here. So the interquartile range is kind of a nice measure of, this is sort of where the middle 50% of the data lies. So there's the interquartile range. So then here's a sample. 12 commuter students were selected from a college. Here's a typical one-way commuting time for these 12 students. We have 3 questions to answer. Find the values of the 3 quartiles. Where does the commuting time of 47 fall in relationship to the 3 quartiles? And then finding the interquartile range. So then this will kind of show how we can solve that. In order to find the quartiles, we first have to rank the given data in increasing order. So remember, when we talk about ranking data, that means putting it in some sort of order from greatest to least or least to greatest. Normally least to greatest, but there are other applications of greatest to least. So here are all 12 pieces of data in order. We find the second quartile, which is also the median. Since we have 12 values, remember that the median then is going to be in between the 6th and the 7th one, meaning we need to go ahead and find the average between those two. So the 2 middle numbers are 29 and 37. So we'll add those together and divide by 2 to find the median, which is 33. So quartile 2 is 33. That's also the median. Okay, so remember those are really interchangeable, the second quartile and the median. Okay. Next, we'll find the median of the values that are smaller than quartile 2. So here are the 6 pieces of data that lie below 33. Remember, 33 was our second quartile. Here they are. And of course, because we're dealing with a median and we have an even number again, we have to take the 2 middle ones and find their average, which happens to be 17.5. There it is. Then we need to find the third quartile. So we look at all of the data that is above the second quartile, which was 33. So here are the 6 pieces of data above that quartile. Here's what we get. And again, because we have an even number of data points, we have to find the average between the 2 middle ones. So 42 plus 47 divided by 2. And the third quartile is 44.5. Now we can sort of look at a summary of all the calculations we did on the quartiles. So it kind of makes sense. We have 12 pieces of data. If we divide that into 4 equal parts, there's 3 pieces of data for each part, which is what we have. So that makes sense. So the value of the first quartile is 17.5. The value of quartile 2 is 33. So half of the students commute for less than 33 minutes, and the other half commute for more than 33 minutes. And then we have 44.5 minutes. So now we know that 75% of the students commute for less than 44.5 minutes, which would be here. And then we have a few few that commute a little bit longer than that. If we look at the position of 47 minutes, we can state that this value lies in the top 25% of commuting time. So again, looking here, I wanted to know where 47 was in terms of quartiles. It's in the top quartile, so it's in the top 25% of commuting times. And then the last question was about the interquartile range, so the difference between the values of the third and the first quartiles. So we subtract those 2 values. So now we know that half of the there is a range of about 27 minutes. So half of the students are within 27 minutes of each other on their commute times. That's what that means. Okay. Here's another example. This one they don't go through and really give you the final answer or show all the steps. So I want you to try that on your own. So this will be a place where you're going to pause the video so you can try it out yourself, just to make sure you know what's going on while you can see an answer. So the following are the ages in years of 9 employees at an insurance company. We're going to find the values of the 3 quartiles. Where does the age of 28 years fall into the relation to the ages of the employees? And then we're going to find the interquartile range. I should have said pause it now, and then I'm going to show you the answer, but I already kind of showed you the answer. So here it is. So this is kind of interesting. So now when we have an odd number of data points, notice that we find the second quartile is the median, which is the middle point. Then this point does not get included when we're trying to find the first quartile and the third quartile. Okay, so now we're down to these 4, right? Less than the median. That's these 4. So we have to find the average there. And then values greater than the median, we have to find the average there. And we get the 3 quartiles at 30.5, 37, and 49. The question said, whoops, too far. Where does 28 fall? And of course, we can see 28 down here. If this is quartile 1, 28 is actually in the bottom 25% of all ages. So that person is fairly young for the company. The interquartile range is calculated by just subtracting quartile 3 minus quartile 1. We get 18.5 years. So hopefully finding quartiles and kind of interpreting what that means when you're looking at a data set is making sense. Okay. Next, we're going to talk about percentiles and percentile rank. So each of these portions contains 1% of the observations of a data set arranged in increasing order. So, of course, in a data set, there's 100%, but we start with P1, the percentile, and the last percentile is the 99th percentile. So that's kind of interesting if you've ever thought about test scores, or sometimes ACT scores come back and they say, oh, you're in the top 50 percentile, or you're in the 75th percentile, or you're in the 94th percentile. You cannot be in the 100th percentile. 99th is the highest, meaning that you're higher than 99% of the people. But, you probably fall in that last 1%. That's as far down as it gets broken. So to calculate percentiles, the approximate value of the kth percentile. So again, this is going to be whatever we're talking about, denoted by P sub k is P sub k. And then it's the percentile that you're talking about, whether it's 70th percentile, 20th percentile, 85th percentile, 92nd percentile, times n. N is the number of the sample size, how big the sample is, and then divided by 100, or 100, is how we get P sub k, or the percentile of the data. So let's take a look at an example. I think this will make more sense. So we're going to refer to this data on one-way commuting times again that we talked about already with the 12 students. And we want to find the value of the 70th percentile. So we want to know, who's maybe commuting less than, other people. So we're going to give a brief description. So here's what we do. We rank the data. Okay. There it is. We've already done that once. Now, since we're talking about the 70th percentile, we're going to use K as 70. We have 12 pieces of data, so that we're going to take that times 12, and we're going to divide it by 100. That gives us 8.4, which means we're talking about the 9th term is going to be the 70th percentile. So notice that we took 8.4 and rounded it up, and it mentions here that this is always the case when calculating your percentiles. You'll always round up. You won't ever round down. Even though normal rounding rules would tell us this would go down to 8, it's going to go up. Okay. All right, so the 9th term. So then we find the 9th term, which is 42 minutes. So we can state that approximately 70% of students commute less than or equal to 42 minutes. That's what a percentile rank is. Okay, 70% of the people commute less than 42 minutes or equal to 42 minutes. 30% of people then commute more than 42 minutes. Okay, if we want to find the percentile rank of a value, we take the number of values less than a certain value divided by the total number of values in the data set times 100. So again, this is sort of like finding a rank or finding a percent. Refer to the one-way commuting again. Give a brief interpretation of this find the percentile rank of 42 minutes and give a brief interpretation. So we follow the steps. We rank the data. It's been done before. How many are less than 42? Okay, in the data list, we have 1, 2, 3, 4, 5, 6, 7, 8 that are less than 42. Let's see, sorry. Yep. And then step 3, find the percentage. So 8 divided by 12 times 100 is 66.67. Or we're going to round this always, and it says nearest integral value, so that's like a whole number. And we can state that about 67% of students in the sample commute for less than 42 minutes. Okay, remember that 70% commute less than or equal to 42 minutes. Okay, that's why there's a difference in those two pieces of information. Okay, that's it for this section. I'm going to put the assignment in the Canvas assignment because I'm about 5 seconds from running out of time here. But that's basically it for quartiles and percentiles.